Welcome. So now we're going to learn about cosine ratio. Right? So different ratio, we use different sides. And every angle has a tangent ratio and has a cosine ratio. Right? So definition of cosine ratio for any right angled triangle, the cosine, so that's just theta. Right? So we always have to take a cosine or a tangent of an angle. Right? We have to start with some angle. Right? So the cosine of our angle theta here is equal to the adjacent side over the hypotenuse. And I don't know why there's an S there, but triangles only have one hypotenuse, so we'll just cross it off. All right, so adjacent side over the hypotenuse. All right, so the cosine ratio also corresponds to an acute angle in the triangle. It is the ratio of the adjacent leg divided by the hypotenuse. And you have this in your notes. All right, adjacent, so the leg adjacent to the acute angle and the hypotenuse. All right, so here's our first one. All right, so when the cosine ratio is written, always start with an acute angle as the starting point. We never use the right angle. Suppose we want to find the cosine ratio for angle R. All right, so that's going to be the adjacent leg over the hypotenuse. All right, so adjacent leg is the leg that makes up part of the angle. There it is. And then the hypotenuse is always opposite the right angle. So the cosine for angle R is going to be the adjacent side, which is side S, over the hypotenuse, which is side T. All right, so the adjacent to angle R is leg S. The hypotenuse is side T. So the cosine of angle R is going to be S over T. And of course, we can take the cosine ratio of the other angle. All right, suppose we want to find the cosine ratio for angle S instead of angle R. Remember, cosine is adjacent over hypotenuse. The leg adjacent to angle S is leg R. Right? So this is the adjacent side, and it makes up part of angle S. And of course, the hypotenuse is always opposite the right angle. So the cosine ratio for angle S is going to be R over T, the adjacent side for angle S and the hypotenuse for the triangle. All right, so this one's in your notes. We want to choose the correct cosine ratio for angle Q. All right, so there's angle Q. Adjacent, we're doing the cosine now. Adjacent side is the leg that makes up part of angle Q. All right, so that leg right there is going to be the adjacent. Come on along. And of course, the hypotenuse is always opposite the right angle. So side R there is the hypotenuse. So you can label the triangle in your notes, and you can write that the cosine ratio for angle Q is going to be side P over side R. Right? So number 2 here, side P over side R, the adjacent side over the hypotenuse. Identify the correct cosine ratio for angle R and angle S. All right, so I'm going to start with angle R because, well, that's when it's first. Notice same triangle here. I believe this one's in your notes. All right, there's angle R. All right, so the adjacent side makes up part of this angle. All right, so this is the adjacent side for angle R. We saw that we were working with tangent, right? We used adjacent for tangent as well. And the hypotenuse is always opposite the right angle. All right, so the cosine ratio for angle R is going to be the adjacent leg over the hypotenuse. So that would be 2 over the square root of 11. Now we have a problem because that's not rationalized. So we're going to multiply the numerator and the denominator by the square root of 11. So that's going to be 2 square roots of 11. Now, if you remember what the last problem was, right, we had the square root of 6 times the square root of 6, and that gave us the square root of 36, which was just 6. So now can you figure out what the square root of 11 times the square root of 11 is going to be? Now, if you got stuck, you could say it's the square root of 121, which, hey, what's the square root of 121? It's 11. All right, so a square root of 11 times the square root of 11 is the same as the square root of 11 squared. Right, and the square and square root will cancel. Right, so we're going to have 2 square roots of 11 over 11. That's going to be in simplest form. Now I'm just going to get rid of this because this has absolutely nothing to do with this problem. So that is our answer in simplest rationalized form. All right, so now we want cosine of angle S. Angle S is on the other side of the triangle. The hypotenuse isn't changed at all. Just our adjacent side has changed. All right, so now this side is the side that makes up part of the angle. Right? This is the adjacent side for angle S. And so we'll just move this over to the other side. All right, so then we'll get rid of this arrow here. All right, so the cosine ratio for angle S is going to be the adjacent side to angle S, which is 3. And we're still going to have the hypotenuse, which is the square root of 11. And that's still not rationalized, so we'll multiply by the square root of 11 over the square root of 11. And now having seen what you got when you multiplied 2 square roots of 11 over the square root of 11 over the square root of 11, I think you'll probably figure out it's 3 square roots of 11 over 11. Because the square root of 11 times the square root of 11 is just the square root of 121. And the square root of 121, well, that's just 11. It's a perfect square. All right, so this is another one, and this one I believe is in your notes. I think this one might be the, nope, there's one more. This one, and then this is the last one on this particular podcast. See, we're getting faster. Did you get the hang of these? All right, so now we want cosine for angle B. Here's angle B. No matter what, oh, here's the right angle. I just got erased. So if it's not in your notes, because I think this one is, just throw in the right angles. And so the cosine ratio for angle B is going to be the, of course, opposite the right angle is the hypotenuse. And the side that makes up part of angle B is the adjacent side. All right, so the cosine ratio for angle B is going to be 6 divided by 2 square roots of 34. So first of all, we could rationalize, and second of all, we could reduce. All right, 6 and 2 are both divisible by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. All right, so that would give us 3 over the square root of 34. And secondly, we can rationalize, and we'll multiply by the square root of 34 of the square root of 34. So students might say, well, why did you choose that number? All right, because if I multiply a number by itself, it's going to make it a perfect square. And I want it to be a perfect square. All right, that's the number I need to use. All right, so 3 times the square root of 34 is 3 square roots of 34. Square root of 34 times square root of 34. I hope you got the hang of the pattern here. All right, and it's going to be whatever 34 times 34 is. But when I take the square root, 134 comes out, 134 goes away. It's just 34. So 3 square roots of 34 over 34 is our answer. All right, so now we want the cosine ratio for angle C. All right, so same hypotenuse, but now the adjacents over here. Let's get rid of you because we're working with angle C. And the side adjacent to angle C is the side that makes up part of angle C. All right, so the cosine ratio for angle C is going to be 10 over 2 square roots of 34. Of course, we could reduce again. Both of those are divisible by 2. 10 divided by 2 is 5, and 2 divided by 2 is just 1. That's going to give us 5 over the square root of 34, and we'll just rationalize again. And I think you got the pattern now, right? 5 square roots of 34 over 34. Right, and that's our answer. All right, now let's try this one. This one's a little bit easier problem. All right, so we have cosine for angle E. We already got the little theta there in E. No matter what, this is the hypotenuse. Oh, you know, I wanted to switch colors too, so that you could see different colors. I don't think it all, oh, it all came together. Let's see if I do that. Well, let's do purple since, look at that. It changed color altogether. Kind of wanted to color code it so you could look at the problem and see, okay, that's the first problem, that's the second problem. So we'll do the third problem in blue. But I'll keep the theta. All right, so hypotenuse is opposite the right angle. So 5, there's the hypotenuse. And if we're working with angle E, this side would be the adjacent side. So this is a really easy one. After doing all that work with the rationalizing and the reducing, this is just 1 over 5. All right, so now we want the cosine ratio for angle F. And of course, the hypotenuse won't change, just the adjacent side. So the adjacent side is now this leg, because this leg is the one that makes up part of angle F. So that's our adjacent side. All right, so our cosine ratio, I'll use a new color, I'll use green. The cosine ratio for angle F is going to be the adjacent side, which is 2 square roots of 6, over the hypotenuse, which is 5. No reducing here, but we do need to rationalize. So we'll what am I saying? We don't need to rationalize. I just looked way too quickly. I was just expecting to rationalize. We're done, right? Because the radical's in the numerator. We don't care about that. We just don't want it in the denominator, right? So we're done. This problem is done. 2 square roots of 6 over 5. That's in reduced form. I was just in a rationalizing mood. Well, I'll get to rationalize, I'm sure, maybe in another problem. All right, so we're done with cosine. We're going to learn about our last trig ratio in the next podcast. Bye for now.